Let's look at some integration with U-substitution, and all of these problems involve trig functions. And if you want to print out the problems, they can be found on a worksheet that I give my students, and here is the bit.ly link right here, so you can go there and print it if you would like. I'm going to jump around on that sheet. The sheet has about 50 problems, but I'm certainly not going to do all of them now. Let's start with number 21. Which is the sine of 7x, and I'm looking at that and I see 7x inside my sine function, so that's where my eyes are drawn for a choice of u. Now the most important part of u substitution is making sure that du is accounted for. It's not so much the u, it's the du. We're really focusing on the derivative of your choice for u, and so the derivative of my u is 7 dx, and so I'm looking at the problem and I want to account for 7 dx. I need to see that. Well, I see the dx. All I'm missing is a 7. That's not a problem. If all you're missing is a constant, you can throw that in there. But I did multiply by 7 to create my du. So if I multiply by 7, I need to divide by 7 as well to undo that change that I made. But I'm going to divide by 7 not on the inside of the integral, but on the outside with a 1/7. And so I'm preserving the same problem. I have a 1/7 and a 7, they cancel each other out. So now that I see my du right here, once you see the du, you are ready to go on with substitution. The 1/7 on the outside comes along for the ride, and I am left with, once I substitute my du, I always substitute du first, then I'll look at the rest. Sine of 7x will become the sine of u. So I take the u and I plug it in for the 7x. And the antiderivative of sine is negative cosine, so the answer is negative 1/7 cosine of u. I misspoke, that's not the answer, that's an in-between step. The actual answer is negative 1/7 cosine of 7x. If your problem starts in terms of x, it should finish with x's if it is an indefinite integral. For definite integrals, you'll get a number answer, and it doesn't really matter as long as you do your substitutions correctly. So moving on, next problem I wanted to look at is number 22, cosine over sine squared. And in the case of substitution, you very frequently take your u from the denominator, and very frequently your u is the entire denominator. This is not going to work, but I want to show you what happens if you choose the wrong thing for u, because it happens quite frequently. If you choose u to be sine squared x, and then you find the derivative of sine squared x. Now remember your du, when you find your du initially, after your choice of u, you're just doing the derivative of what you chose. The derivative of sine squared, you bring the 2 down, leave the sine x alone, and then times the derivative of sine x. It's a chain rule. That's a chain rule. So I see that as my du, and so now I'm looking at the problem, and I want to see that in my original problem. Well, I've got a lot of problems here. I've got an issue. The cosine shows up. The dx shows up. I can account for the missing 2. However, I do not have the sine x. That is not up here in the denominator anywhere. And that means that I chose a poor thing for u in this case. The actual choice of u is going to be cleaner than that. And you need to remember that the most important part of u substitution, it is the identification. It is finding your du. And I'm looking at this problem and I see cosine x in the top, and I really like that because I know that cosine x is the derivative of sine x. So I'm not going to let my u be sine squared. I'm going to let u be only the sine x. And I'm doing that because I know the derivative of sine x is cosine x dx, and that is in the problem. I am able to identify the du if I choose sine x for u. So make sure whatever you choose for u, its derivative can be found in the problem. And if you can find its derivative, then you can go on with the substitution. So I'm going to substitute here, substituting the du first. So cosine x dx, that comes out. Du will take its place. Because the cosine x got wrapped up in the du, I'm going to put a 1 in the numerator. My denominator of sine squared will be u squared, and then we'll do that antiderivative. So now we have a nice power rule. We'll bring that u squared up to the top. U to the negative 2's antiderivative is u to the negative 1 over negative 1. And now we just have to substitute sine x back in for the u. I'm also going to rewrite this. I'm going to move that u back to the bottom. So it's negative 1 over sine x plus c. And if you're feeling fancy, you can call that negative cosecant x plus c if you want to. The only reason you would want to do that is if it's a multiple choice question and you have to match your answer to something in the multiple choice options. So let's move on. Number 27, the cosine of arc sine x over root 1 minus x squared. There are two different ways to do this, and one way would bypass the substitution method. However, because I am trying to teach substitution and give you examples of substitution, we will work this as a substitution problem. And one thing you should see in this, after you are first shocked by how ugly it looks, you should see arc sine x, and you should know that the derivative of your inverse sine or your arc sine of x is 1 over root 1 minus x squared. And I kind of see that in the problem. I have over root 1 minus x squared dx. That's the derivative of arc sine x. So I'm going to choose that arc sine x as my u. The derivative of arc sine x is 1 over root 1 minus x squared dx. And I'm looking at my problem and I want to see that, and I do, because I have my 1 over root 1 minus x squared right here, and the dx is going to come along with it. There is my du. So now I'm ready to substitute. So I take out the du first. Take all that stuff out and I replace it with du. Then I look at what's left. I have cosine of the arc sine of x, and that arc sine x is going to be u. So we are left with the cosine of u du. The antiderivative of cosine u is sine of u. And so then we substitute the u back in, and my final answer is the sine of the arc sine of x plus c, which is correct. It does turn out that sine of arc sine, they are inverses of each other, so they kind of undo each other. That is the same thing as x plus c. And the other method I alluded to a few minutes ago, where you bypass the U-substitution, would have taken you to just x plus c. But it's more of a geometric way of looking at it and cleaning up this integrand before you do the antiderivative. So both are acceptable answers. All right, two more. The sine of 2x over x. And so if you look at the sine of 2x over, not over x, over sine x, this one's interesting because the arguments are different, and you typically want what's inside your trig functions to be the same. This is a unique problem. It's actually not a u substitution. You could try a whole bunch of things for u. You may try u equals sine x, but the derivative of sine is cosine, and I don't see cosine in here anywhere. You could try u equals 2x, but the derivative of 2x is just 2 dx, which I could create, but that still leaves a whole bunch of other things to have to substitute, and it doesn't really work out too well. This problem, we're actually going to avoid substitution. Substitution will not work, and we're going to channel our Algebra 2 and Pre-Cal minds, because a trig identity, the double angle identity for sine 2x, will come in handy here. It is one of the few identities we use in AP Calculus. You don't use as many as you learned in Algebra 2 and Pre-Cal, but one of them that we will use is the identity that sine of 2 theta is 2 sine theta cosine theta. Now that's not calculus, that's not a derivative or anything like that. That's just an identity. Those two things are equal, and so that will allow me to take out the sine of 2x, and I can replace sine of 2x with 2 sine x cosine x over sine x. The sine x's will cancel, and I am left with just the antiderivative, 2 cosine x, which that's recognition. Cosine is the derivative of sine x, so the antiderivative of 2 cosine is 2 sine x plus c, and we're done. So there was no substitution on that one. It was just a trig identity that cleaned up and made the problem very nice and very straightforward. Well, after you substitute, after you do the identity, it's very straightforward. But the recognition of using that, I don't know. We will see sine 2x, and it's a fairly nice, clean identity. You need to know that one. And then the very last one is kind of similar, Now, this one is a little bit more tempting to try U substitution because we had the reciprocal of this problem earlier. We had cosine over sine squared, and in that problem, we did let u equal sine x, which, by the way, this will not work. I'm just going to show you what happens. The derivative of sine x is cosine x dx, and you may be tempted to say, hey, I see cosine x dx in the problem, but you don't. You don't see cosine x times dx. What you actually see here is 1 over cosine x dx. If you rewrote this problem, this is the same thing as sine squared x times 1 over cosine x dx. And 1 over cosine x is not the same as cosine x. So that did not work. That was not the correct substitution. You could also think, well, I do know that the derivative of cosine is negative sine, and we could kind of do that. I could separate sine squared into sine dx over cosine x. I could try this. If u was cosine x, the derivative of that would be negative sine x dx. I could put a negative in front of this sign, a negative out here, and I have my du, I have my u, but the problem is I have not accounted for this extra sine x out here. I have not substituted that out yet. So that u, while coming close, didn't get everything, didn't work. So this is going to be another one where we use identities to clean it up. In this problem, what we're actually going to do is replace sine squared with 1 minus cosine squared, just your Pythagorean identity. 1 minus cosine squared x over cosine x. And then we can split that fraction into 1 over cosine and cosine squared over cosine. So we have 1 over cosine squared, or 1 over cosine x minus cosine squared over cosine x. I'm going kind of fast here. 1 over cosine x is secant x. Cosine squared over cosine x is cosine x. And so we have two antiderivatives. The second one should be easy. The antiderivative of cosine x is just sine x. So we're going to finish with negative sine x plus c. The antiderivative of secant x, in a weird manipulation, it's actually a U substitution problem. However, it's so bizarre, I encourage you to just memorize that. And it turns out that the antiderivative of secant x is the natural log of secant x plus tangent x. I will, in class or maybe in another video sometime, explain how that happens. It's just a bizarre little trick where you have to multiply the top and bottom of that fraction, which you don't even see the fraction of secant x plus tangent. Anyway, it's a mess, but that's one that I'll encourage memorizing. And there is your answer for that one. So last two problems were just examples of how to use trig identities to manipulate problems when U substitution fails. So last two were not U sub, but I want to throw them in anyway, and now I'm rambling. Goodbye.